Jai Shri Krishna. Good morning, students. I am your science teacher. My name is Swayam Kanodia. Today, I am going to teach you a particular easy and important topic of physics, that is series and parallel connection. Every year, at least one question is asked related to this topic in board exams. So, let's start our first type of connection, series connection. What is series connection actually? When two or more types of resistors are connected in particular way such that the current in a circuit is same but voltage is different in across all over the circuit. So let's draw a diagram of series connection. This is our first resistor, that is R1. This is R2 and this is R3. This is the schematic diagram of actual series connection. So we can say that the direction of the current is unidirectional. That is only one direction of a current is all over the circuit. This is the flow of a current and this is the direction in such a way that current is flowing in this circuit. Okay, this is first resistor R1, this is R2 and this is R3 and this is our battery and I have denoted it by V. Okay, here the value of V is different for every resistor, that is V1, V2 and V3. How we can find this? By applying Ohm's law. Okay, so let's apply the Ohm's law separately on each resistor. So what is Ohm's law? V is equal to IR. We are going to take R1 as a resistor. So we put R is equal to R1 and this is our V1. And let make this our first equation. Okay. Let's same way V2 is equal to IR2, V3 is equal to IR3. This is our first equation, this is second and this is third. The V is distributed all over the circuit. So we can write it by V is equal to V1 plus V2 plus V3. Okay. So how we can find this V? I am assuming that all three resistors as a one resistor and I name it as RE, that is equivalent resistor. Okay, and this is our V. So we can find V is equal to, the current is I as it is same in all over the circuit, IRE. Now putting all this equation, so we get IRE is equal to IR1 plus IR2 plus IR3. As the current is same, we can take I common from above equation, that is our equation 5. So we get RE is equal to R1 plus R2 plus R3. So this is our required resistance value which we have to derive in board exams. Let's do a numerical related to this type of connection to better understand of the topic. A question is given here: an electrical lamp whose resistance is 20 ohm and conductor of 4 ohm resistance are connected to 6 volt battery. I draw the connection here. We have to calculate total resistance in the given circuit, current in the given circuit, and third, potential difference on each component of the circuit. Okay, so let's find our first total resistance. So total resistance can be given by RE is equal to R1 plus R2 because it is connected in a series connection. So we have just derived the series connection formula, R is equal to R1 plus R2 plus R3. But here two components are given. That's why we are using R is equal to R1 plus R2. So the value of R1 is 4 ohm and value of R2 is 20 ohm. So the total resistance of the circuit is RE is equal to 24 ohms. So we have find the first question, that is total resistance. Now we have to find the total current in the circuit. So we can find the current by applying Ohm's law. I is equal to V upon R. But here R is equal to Ra. That is our total resistance. I is equal to, the value of V is 6 volts and Re is equal to 24. So by dividing this we get 1 upon 4. So I is equal to 1 upon 4 ampere, or we can write it as 0.25 ampere. Here the value of current is 0.25 ampere. Now we have to find the third question, potential difference on each components. So by using Ohm's law, again we can find the value of first resistance, that is V1 is equal to IR1. I is equal to 0.25 and R is equal to 4. So we get V1 is equal to 1 volt. So first component is given, and third V2 is equal to IR2. I is equal to 0.25 and R is 20. So we get 5 volt. So V2 is equal to 5 volt. We have find the all three components or all three questions in this given question. At our second type of connection, that is parallel connection. This type of connection is just opposite to the first one, that is series connection. Here I is different, that is current is different in all over the circuit, and potential difference V is same. That's why I am saying that it is just opposite to the first one, that is series connection. So let's build our circuit. Here is our battery, that is I am denoting it by V. This is R1, resistor 1, second resistor R2, third resistor R3. But here the direction of the current is different, that is unidirectional. I1, I2, I3. Current is distributed all across the circuit, and we get at the end the same amount of current in the circuit, that is I. Here V is same, so let's start our derivation by applying Ohm's law on each component separately. We get V upon R1, because we are finding the value of a current in first resistance. We get I1 is equal to V upon R1, first equation. I2 is equal to V upon R2, second. I3 is equal to V upon R3, that is our third equation. Now let us assume this all component as a single resistor or single component, that is our Re. So we can write the value of I in this circuit. I is equal to V upon Re. That is our fourth equation, equation number 4. Now we have to find the total current in the circuit. I is equal to I1 plus I2 plus I3. Now putting all the 4 equation in this equation, we get V upon Re is equal to V upon R1 plus V upon R2 plus V upon R3. As V is same here, so we can take V common from above equation. We get 1 upon Re is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That is our required equation that we have to derive in boards. Let's do a numerical related to that type of connection, that is parallel connection, for better understanding of the topic. In this question, there are three sub questions, that is in our circuit, three resistors R1, R2, and R3 have value 5 ohm, 10 ohm, 30 ohms, which have been connected to a battery of 12 volt. Calculate current in each resistor, total current in the circuit, and total resistance in the circuit. So first we have to find the current in each resistor by applying Ohm's law. We get I1 is equal to V upon R1. Here the value of V is same for all resistors, that is 12 volt, divided by R1 5 ohms. So we get I1 is equal to, this been cancel out, 2.4 ampere. Okay, this is the first current that is flowed in first resistor. Now we have to find I2 for second resistor, V upon R2. Here value of V is 12, R2 is 10. We get 1.2 ampere. So I2 is equal to 1.2 amperes. Okay, this is I2. Now we have to find I3 for third resistor, V upon R3. 12 upon 30, because the value of R3 is 30. We get 0.4 ampere. I3 is equal to 0.4 amperes. Okay. Now we have to find total current in the circuit. So by applying I is equal to I1 plus I2 plus I3, we get the total current in the resistor here circuit. Okay. So I is equal to 2.4 plus 1.2 plus 0.4. So we get I is equal to 4 ampere. This is the total current flows in the circuit. Now third, we have to find total resistance. So by applying the derived equation, 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, we get the total resistance of the circuit. So 1 upon Re is equal to 1 upon 5 plus 1 upon 10 plus 1 upon 30. Okay, so now by taking LCM as 30, we get 1 upon Re is equal to 1 upon 3. So by taking the reciprocals common, we get Re is equal to 3 ohms. That is the total resistance of the circuit. So here our equation or numerical is completed. Hope you understand these topics. Thank you very much.